All right, so today we're going to start on quadratics. The last chapter we talked a little bit about all things and transformations of various different kinds of graphs. We just kind of threw them all in together. And so this chapter does the same thing, but we are going to turn around and be able to just focus on one particular type of function at a time. So we're going to kind of slow things down just a tad bit. And so when you look at this, we're going to be able to analyze the graphs of a quadratic function, write quadratic equations in standard form, be able to sketch them, find the min and max. So truly something that you pretty much have got hit with during chapter 1. But now it's just going to be focusing in on quadratics and adding a little bit to it. So when we go over here and look at this, what is the definition of a polynomial? So bottom line, I think a lot of times they like to ask this question on the SAT or the ACT. One of them, I see that several times. But what is a polynomial? Well, it's basically an addition and subtraction, a sum and difference of a bunch of terms. The only catch is that the A's, the coefficients of all the terms, have got to be real numbers. And what I mean by that, they can't be imaginary, and they can't be the ends are, yes, the A's can be anything. They could be a square root of 2, they could be a square root of 3. They've just got to be real. And again, if we think of our number system, we have this complex number system, and then immediately it's divided into real and imaginary. And so we're talking about all the real numbers. In other words, you shouldn't get an imaginary number in front of the x or be a coefficient. And so then the other thing is that your exponents, all the ends, they have to be positive. They can't be a negative one. So a negative one usually appears as the rational because that's the 1 over x, which raises it to x to a negative 1. And so you can't have any basically variable in a denominator. That would not be a polynomial. Does that make sense? So we're going to look at this and say you have polynomials are classified by their degree. Well, you have the first polynomial, which is your constant function, parent graph being y equals 0, correct? You got your y equals 0. And so that's just a horizontal line. And that's what a constant function is. They're just horizontal. Then we know comes in the what? Well, then we come in with the linear functions. Well, what do we talk about a linear graph? Well, those are the ones that can be increasing or decreasing, correct? And so it's usually can be y equals, that's a linear. You got a slope and you got a y-intercept. Good. So I better keep my mouth shut about vertical and horizontal. I was trying to bring those in. But a linear function, we typically think of it as going up or down. Yes, a horizontal equation could be written in the form y equals mx plus b, but your slope would be 0. So here your slope is something other than 0. And that's what that's telling you right there. The slope, if it's 0, then you've got a constant function, okay? And then we're not ever going to talk about x equals a number because that's not even a function, right? X equals 12, it's a vertical line, so that's not even going to be a function. But it has a degree of 1 because of that exponent being 1. And then this has no exponent, so it doesn't have a numerical value. So it has a degree of 0. So it has a degree of 0. Everybody good there? Okay, the next one is quadratic, and this is where we're going to spend our time. A quadratic is a degree of what? 2. And again, we've got to understand, and I think if you just kind of tie this in, this little extra bonus here, but this is going to tell you how many answers, how many x-intercepts are you going to have? 1. Right? When you go to solve, you're going to get x equals 1. There's going to be 1 answer. When you have a quadratic, how many answers are you going to have for your x-intercept? 2. And so again, that could be what we call a double root, meaning that, hey, we might have 2 answers, but they're the same thing. Correct? That's possible. Like if I have x plus 4 quantity squared, x plus 4 times x plus 4, we get 1 answer, it's negative 4, but it pops up twice. Does that make sense? Okay. And so now here are the basic characteristics of a quadratic. So to quadratic, and again, some of this should be stuff that you already know. If the coefficient in front of your quadratic term is positive, so if this is positive, A is positive, you know the graph is going to go up. You know the graph will go up. It's just guaranteed. We know the domain of a quadratic is all real numbers. It's negative infinity to infinity. Why? Well, because there's no square root, there's no even root, and there's no fraction that we're talking about where the variable's in the denominator. What's the range? The range starts out and goes from 0, that's your outcome for when x equals 0, and then it just gets bigger. And again, it should make sense because when we square numbers, they're always going to be positive. So they're always going to end up here in the first and second quadrant. Then you have the x and y intercept are at 0, 0. And then we can go ahead and talk about our decreasing and increasing. The graph as you come in from the left decreases from negative infinity to 0, and then it's going to increase from 0 to what? Infinity. Remember, you use your x values to determine increasing and decreasing. You never use your y values. It's always x to determine that increasing and decreasing. We also learned from chapter 1 that it's also even, because if I throw in a negative x and I square it, I don't care what the number is, negative 5, negative 10, negative 1/2. When you square it, it comes out positive. So that's going to have symmetry around the line y equal, or around the y-axis, which is actually the equation x equals 0. And then we know we have a relative minimum at the vertex at 0, 0. So again, we're probably going to bring in the word 0, 0 just a little bit. Now you go over to the next one. If you know that you have a quadratic and a is less than 0, so in other words, that means a is negative. Again, the domain's not going to change. It's still negative infinity to infinity. I can throw any number in there and square it. And then I can say, okay, but now the range is going to be from negative infinity to 0. Why is it going to be from negative infinity to 0? Well, when you flip it over the x-axis, which is what that says, when a is negative, you're going to flip it over the x-axis, reflect it over the x-axis, then everything that was positive will now go negative. And so that's why it's going to go from negative infinity to 0. The intercept is still going to be at 0, 0. Now your increasing and decreasing intervals will change as well. It's going to go increase from negative infinity to 0, and then 0 to infinity. It will be decreasing. It's still going to be even. It still has an axis of symmetry on the y-axis, or at the equation x equals 0. But this time around, it'll be a max. So you can correlate. If you have a is negative, you should be able to tell me, hey, it's going to open down. It's going to have a max, minimum. And if you should sit there and say, oh, if a is positive, it's going to have open up, and it's going to have a minimum. Does that make sense? Those should be tied together. All right, so now we're ready to look on this. I think I just talked about this, and so that's what we're going to look at. So what I just confirmed is that the fact that, you know what, if you know your parabola is going to open up, then you know it's going to have a minimum. And if you have the a is negative, you know it's going to have a maximum. And so the vertex will be the highest point if a is negative, and then if a is positive, you know you'll have a minimum, and the vertex will be that minimum. Does that make sense? So your vertex is your max or min. The vertex is your max or min. So here we are. Let's graph. And so nothing new. You're going to see that we have a lot of repetitives. That's what that thing likes to do. And so if we look at this, we have to graph it. So let's graph A over here. We've already done this. You've already been tested on it. What's the transformations? It's going to reflect over the what? X-axis. And now it's going to do also go up what? 1. So it's going to reflect over the x-axis and go up 1. And so let's graph that. You're at 0, 0. You reflect over the x-axis, and then it goes up 1. Then we're going to turn around. We are at 1, 1. And we're going to reflect over the x-axis. So we'll be at 1, negative 1. And you move up 1. You know that because of the symmetry, because it is a square, that the other point would be negative 1, 0. Again, you can do the same math. You could be at negative 1, 1. You reflect over the x-axis and you go up 1. Then we're at 2, 4. Reflect over the x-axis. You're going to be at 2, negative 4. And then you have to go where? Up 1. And I hope I'm there because I like my eyes. 1, 2, 3. Right there is where I would be. And then because of the symmetry deal, you know it would be in the same spot. So again, you've already seen this, already done this. This should be old school. But two things that you probably already thought about, but we're adding to the table now, is that, oh, that's got a negative a. It's going to have a max. Oh, it's going to open down, right? Which that's stuff that you probably already knew. Okay, so, and then the max is the vertex. So what is the max? The max is the vertex, and that point is at 0, what? 1. So we have a max there. The next one, can we also find the x-intercepts? Yes. So I'm going to ask that question too, because that's an old school question. What's the x-intercepts there? Well, you can see it. It's going to be what? Plus or minus 1, comma what? 0. The question is, how do you get it? How do you get the x-intercepts? You set it equal to what? 0. You set it equal to 0. So to get this, you take, what was the equation? Negative x squared plus 1 equals 0, correct? And so you solve that, you get x squared, negative x squared equals a negative 1, x squared equals 1. Oh, what's that x mean? Got two guys, plus or minus 1. Good? So if you can't look at it graphically, you should know how to do it algebraically. Do the next one. What are the transformations of B? What are the transformations of B? Does everybody have that? Am I going too fast? I need to stop. Good. Okay. Now look at B. What's B going to do? What do we say that? Well, this got the transformation here. It's going to tell us what? If it's inside plus 2, that's going to tell us we're going to go where? Left 2 and then down what? Okay. Just as a little insight, right there is your vertex. Right there is your vertex. Right there is describing your vertex because we take what? 0, 0. And that's the first one we move, which is the vertex of an original graph. Right there's your max and min. So or max or min. So is it going to open up or down? It's going to open up. There's no negative out front, so it's going to open up. And so let's graph it and say, okay, well, let's graph. We're at 0, 0. We're going to go to the left 2. And then what? Down 3. And again, we pick a few more points off that parent graph. We go 1, 1. And we're going to go to the left 2, down 3. And then we're going to turn around and we're going to say, okay, we're at negative 1, 1 because of symmetry. We know it'll be in the exact same spot, right, with the symmetry. If not, you just move it. And then we're going to be at 2, 4. And we're going to go to the left what? And down what? And so we will be in the same spot over here as well. And so we graph it. And again, some things we want to make sure we can talk about. We know the graph is going to go open what? Go open up. We now know that the minimum, which we knew it would have because of the A being positive, there's no negative out front, is what? Negative 2, negative 3. Correct? We know that. It's negative 2, negative 3. And then what else do we know? What else can I say that we can find if we want to? The x-intercepts. And how would you find those x-intercepts? Oh, you wonder why we did that worksheet the other day, right? Why we've been working on completing the square and solving quadratics and all that different stuff, because you're going to have all kinds of that stuff. So if we solve that, what are you going to do for the x-intercepts? Add 3. Then what are you going to do? Take the square root of it, plus or minus the square root of 3. And then what are we going to do? Subtract 2. So x equals a negative 2 plus or minus the square root of 3. So is this going to be some nice, neat number like negative 1, negative 2? Nope, it's an irrational number, right? It's irrational. That means if I really want to figure out what the decimal is, I'd have to plug those things in my calculator and figure it out, correct? You have to plug it in the calculator and figure it out because they have them. They're right there, right? And they both look like, unless I messed it up, they both appear to be, they're going to be negative, right? And so we should be able to get those answers by plugging it in. Again, we can look and say, oh, well, let's go ahead and address this. What's the y-intercept on this guy? I didn't address it on the other. We'll go back and address it. What's the y-intercept? 0 what? Now, how do you get that if we don't know how to get it? Plug 0 in for what? X. So to find this, you would do 0 plus 2 squared minus 3. And so if we do that math, that's going to give you 2 squared minus 3, which would give you 4 minus 3, which would be what? 1. Does that make sense? Good? Okay. And so we could do the same thing over here and found the y-intercept. Let's go ahead and put that back on this guy. What's the y-intercept? Oh, not 0, negative 1, 0 what? 0, positive 1, correct? Does everybody agree? Go back and look him. Y-intercept, it's at 0, 1. Good? Make sense? Okay. So next, we have the standard form of a quadratic. Standard form of a quadratic. Here it is. It's the equation, and 1b is written in standard form. So that very first equation, this equation back here, is what we call written in standard form. Well, you know what else we can call it? It's also written in complete the square form. It's also in complete the square form. And that's why we spent time trying to figure out how to complete the square, because we're going to need to know how to do that. And so when we look at this, we're going to say, okay, it's a really special case when you look at complete the square. If we look at it, and if it's in the form a times the quantity x minus h squared plus k, a does not equal 0 in standard form. So what do we know from there? We can tell you that the vertex, I'm going to highlight this so I can do it. is going to be HK. Now, I've got to also remember that we said something about different things. When we have something in parentheses and that minus H, that tells us that we go what? Left to right. That's how we tell we go left to right. So when you come out and you take the vertex, I'm going to star the H. Why am I going to star that H? Because that H is always going to have to come out as a positive or a negative. It's going to come out of the opposite. So right now, because it's minus H, it's going to come in out as a positive H. Because again, it has the opposite movement. It has the opposite movement. So here we go. Let's look and see what this first one is. It says describe the graph. And I need to make that description a little bit better because in your homework, it's going to say describe the graph all the time. So typically, if it just says describe, pretty much all you're going to tell me, does it open, up, or what? Down. So if it's asking you to describe, it's asking you to tell if it's open, up, or down. But again, I'm not a big fan of that. It might also be added to the direction is to tell the what? Transformations. Because it's really easy to tell the transformations once it's in complete the square standard form. Okay, complete the square standard form. You can be able to tell the transformations pretty easily. And you can also tell the vertex very easily. And you can tell the x-intercept's pretty easy and the y-intercept's pretty easy. So a lot of information comes out pretty darn quick when it's in complete the square form. So here we are, another snapshot if you need more examples of complete the square. I was just trying to hurry it up along. So you're going to look at this and now it will be just a tad bit different because we're not solving. Okay, we're not solving. So I'm going to put a little twist on the complete the square because I don't want to solve for x. I just want to get it into a certain form. So what's going to happen is we're going to turn around and say, okay, well, what are we going to do to complete the square? You're going to do f of x is equal to x squared minus 6x. Is 11 what I want there? Because remember from the other day, complete the squares, we want a specific little pattern so we can factor it in a little specific way. And so is 11 the number that's going to be good? No. So if we did this while we were solving, we moved it over to the other side, right? So now this time around, we're just going to push it out of the way. So we're going to come over here and put plus 11 out to the side because I don't want it there. And so what number do I want there? How do we get that number? Remember, it's half of what? Negative 6, which would be what? Negative 3 squared. So what's that number that I want? 9. And so once I put that number there, what did I have to do to the other side? We added 9 to the other side, but I'm not touching the other side because I'm not solving anything. I'm just trying to put it in a nice little form. I'm trying to put it in standard form. I'm trying to make it look like that. And so when I look at that, I'm going to say, okay, well, what are we going to do now? Well, because we added it, we also have this property of addition that says, you know what, I can add 0 to anything and I don't change the equation at all. I don't screw up the equality. So instead of adding 9 here is where I need it, I'm also going to come over here to this 11 that I pushed out of the way and I'm going to subtract 9. Okay, so it's like I'm going to add the 9, but I'm also going to subtract it within the same side. That would be exactly the same thing as if I were to take a negative 11 over to the other side and said, hey, I added 9 here. I'm going to add 9 here. And so, and you can kind of see that because I would subtract 11, but then I would add 9 if I set it to the other side. So now I'm ready to put it in this nice little form. So I did this on purpose so that I could write it a certain way. And what is the way I want to write it? X minus 3 squared. Some of you might need that first step that says it's going to be x minus 3, x minus 3. But if you don't need that, it's just x minus 3 squared. Then it's going to be plus what? 2. Now tell me, what's the vertex? Now you've got some simple math that you can simplify. What's the vertex? 3, 2. Again, because remember, this goes in and out as the opposite, right? They're opposite of what you see. And what's on the outside is what you see is what you get, correct? That never changes. So the vertex is 3, 2. Good? Now, I'm also going to jump ahead of the game, and you're going to see this in just a minute. But the other way to do this is to just use this point. And again, I think you did a lot of this in Algebra 2. I'm not sure. But you just chose part of the quadratic formula because that vertex comes from a certain point. But again, this must be in standard form. So if I look at that, I'm going to say, okay, for this one, I've got x squared plus 6, minus 6x plus 11. So remember, here's your A, here's your B, here's your C. Correct? There's your A, there's your B, there's your C. And so to get the vertex really, really quick, what would you do? You're going to take the opposite of B. What's the opposite of B? 6 over 2 times A. What's A? 1. So you're going to get 6 over 3, which is what?
Wouldn't it be 6 over?
6. Say that again.
Would it be 6 over?
Oh, 2 on a better day if I did bright math. Good, sorry. Yes, 2 times 1 last time we checked was still 2, right? We just tried to make it up that it's 3. Sorry. Okay, so you get 6 divided by 2, which is what? 3. Oh, looky there. Look, same answer, right? Oh, we did it in standard form. We got this guy. Well, I'm going to tell you here which one's easier. I think we all know, right? Do you want to spend the time putting a complete the square, or do you want to just do the opposite of B over 2A? Because it's 10 times easier, correct? Okay. So, and then now what are you going to do? So here's the part that the notation that I worry about. What's this guy mean? I just marked him out. So what does that F mean? Now look at, I'm going to say F of 3. That's what I need to go find, right? So what do you plug it in, right? You plug it in. And so we're going to plug it in just so we have the example on our paper. So we're going to turn around and say, okay, well, it's going to be 3 squared minus 6 times what? 3 plus 11. So we do that math, and you're going to get 9 minus 18 plus what? 11. So you're going to get negative 9 plus 11, which is what? 2. So same question. What's the vertex? Lo and behold, it was the same thing. Surprise, surprise. So again, why would you want to complete the square if you could just do that? Because what does this yield you better than this? This means you're going to either have to factor. If you go back and look at this, let's say the question said, find me the x and y intercepts as well. You're going to have to do something with it. You're going to have to complete the square. You're going to have to do the quadratic formula because it sure as heck's not going to factor. Make sense? So when complete the square is easy, you probably want to do it because it makes your x and y intercept finding, which is also called the horizontal and y intercept, or the horizontal and vertical y-intercepts, makes it pretty easy to do. Does that make sense? Plus, it's in standard form. It makes it easier to graph. It tells you your transformations. You get a lot more information from completing this square. But when I look at this, I can still say that thing's going to open what? Up. And I also know it's going to have a what automatically because it opens up. Minimum or maximum? Minimum, right? So all of that stuff should be going through your head because you can analyze it to death. And unfortunately, when you get higher up in math, that's exactly what you want to do is you want to analyze graphs and functions and figure it all out. That's pretty much what a big part of calculus is. Okay, so here we are. It says to describe the graph. Well, how are you going to, and it says, that's all it says, describe the graph and identify the vertex. So now what are you going to do? Well, again, could I find the vertex really quickly by doing negative b over 2a, comma, then plugging that answer in? Yeah, I could do that really, really fast. But I think you probably want an example of complete the square as well, so that you can describe it with transformations. But right now, if I ask you to describe it, you tell me it's going to go up what? It's going to open up or open down? It's going to open up, and it's going to have a min or a max. It's going to have a minimum, right? So that's the least you can tell me without really doing an investigation. But here we are, complete the square. Does anybody see a problem with this one? And that's why I want to do complete the square on this one.
There's a coefficient.
Yeah, you got a coefficient. And you can't have that. Cannot have that in front of it. And when we solved it, we just divided everything by 3, correct? Can't do that so much because we're not solving anymore. So we just have to kind of deal with it. So we know the formula for a standard form of parabola is what? X times the quantity what? X minus h squared plus what? Okay. This is the complete the square part right there, the x minus h. So when I look at that, let's start the process. So we have y equals 3x squared minus 6x plus 4. Yes, I wrote the whole thing out again, and I apologize. But when I look at that, obviously, what is it that we do not want there? The 3, and we also don't want the what? 4. So my first step is to say, okay, I'm going to keep the 3x squared minus 6x, but I'm going to kick 4 over here. I don't want them in the problem. I don't want them any part around the situation. Get them out of the way. The next thing I'm going to do is I'm going to get rid of the 3. I'm not really getting rid of the 3, but I'm also going to remove it from completing the square process. So what I'm going to do is I'm going to factor it out. If I factor it out, again, I'm factoring it out of the first and second term. the quadratic term and the linear term, the x squared and the x. And so if I factor out that 3, what does that give me? Minus 2x. And then I'm going to close it up, and I'm still going to have my plus 4. So when I look at that and I say, okay, well, let's complete the square. I'm only completing the square of these guys. That's it, just this, x squared minus 2x. So let's ask, what's half of negative 2? Negative 1 squared is what? What number do I want to put up here? 1. I did that on purpose. There was a process that I put in there so that I could factor that thing into what? 3 times what? X minus 1 squared. And then I still have this plus 4, right? So here comes the tricky piece to it, if there's a trick to it at all. If I multiply 3 times 1, which is really what I set that thing up to do, that, hey, I'm completing square. So, parentheses are really important here. So if I set that up, I didn't really just add 1 to that side of the equation. Because if I use my distributive property is probably the better way to say that. What did I really add to that side? 3 times 1 is what? 3. So what do I have to come over here and do? Subtract 3. And that's where most people are going to ask, where did that 3 come from? And that 3 came from distributing the 3 that I pulled out because I can't have it. And so if I'm adding 3, I'm going to use my property of 0 that says, I can add 0 to both sides or any side to one side of an equation, and it will not change the problem. Because do you all agree that 3 minus 3 is 0? So it didn't really change the problem at all. I just added a few extra numbers in there. So now I'm going to add that minus 3 down here. And so what do you get? You get y equals 3x minus 1 squared plus what? 1. You can tell me a whole bunch more now. Is it a lot easier to find stuff now? Yes. Is the vertex, what's the vertex going to be? Vertex is 1, 1. Can you tell me transformation? Vertical stretch by 3, which probably is one of the most missed things on that test. Vertical stretch by 3. We went to the right 1 and what? Up 1. Right? So we have a lot more information that we can tell about this graph by putting it in complete the square form. Could I have done this and got that this was negative 1, got that this was 1, and then plugged this in, f of 1, and said, hey, well, I'm going to get 1, 1. Can you do it that path? Can you go that route? Oh, yeah, you can plug it in. Do I really care which way you do it? It just depends on what the question's asking. Okay, it just depends on what the question's asking. Now, could I also tell you that what's the x-intercepts? Can I find it pretty quick? Yeah. Can I also find the y-intercepts pretty quick here? A lot of benefits. Nothing's more beneficial than saying, hey, what's the y-intercept here, and saying that it's 4, right? I'm not going to take that away. The y-intercept here is 4. If I plug in 0 real quick for x, I automatically see that it's 4. And so kind of when you're in math, that's what you want to be able to do. You want to be able to say, and it's for analyze it. What's the path of least resistance? What gives me the most information? Which one's going to help me the most? And really, complete square has lots of benefits to it. Questions on that? All right. So here we are. Identify any x and y intercepts. So let's look. Describe the graph. What do we know? Unless we put it in complete the square form, what do we know? Just looking at it, what can we tell? It's going to open down. It's going to open down. And that's pretty much about all I can tell. So, but I also can tell that if it opens down, I'm going to have what? A max. So when I look at that right now, describe, I can say, hey, I know it's going to open down, and that means I'm going to have a max. And we know how to find the max on a calculator, right? Left bound, right bound, enter, find it, write the point down. So that's still an option as well for a checking purpose. So it's going to open down and it's going to have a max. Now the question doesn't ask that at all. It just says find the x-intercepts. So again, you get to pick. This is what makes this class a little bit more difficult. If I have f of x equals a negative x squared plus 6x minus 8, how do you find the x-intercepts? Set it equal to 0, because your y value is 0, and you get negative x squared plus 6x minus 8. Now, what could you do? And again, I'm just throwing options out there. That's why we spent a couple days on that worksheet. You think this might look factorable? I mean, that'd be my route. I would go every single time. I would say if I factor that thing, that's the route I'm taking, because that's the easiest route. So if I look at that and I say, well, first of all, and again, I'm going to probably change the tone on you because with the higher up and go in math, you just don't want to get rid of the negative completely. We're going to factor it out. I'm going to put -1 right there. GCF, -1, because that quadratic term is negative. We don't want that. And so when I do that, that's going to change all the signs. And now it's an easier read. Factors of 8 that add to give you -6. Factors of 8 that add to give you -6. Pretty easy. That's the route I'd take. And so what do you do when you do that? You set each one equal to what? 0. So I think the hardest part is that with this is that you get at the crossroads and you're like, okay, which path do I go? Which path do I want to go? And that's what makes it hard. And so again, you want the easiest path. And that's kind of hard to discern sometimes, or not. Sometimes we don't get that. So again, just to kind of make sure that we're good, if that's what you do when you solve it, you're finding the x-intercepts. I don't think we make that connection enough. It just says solve, and we don't really know what we're doing. So it's going to cross the x-axis. It's going to cross at the point 40, and it's going to cross at the point what? 20. So now I got a little bit better of a picture. Still don't know what my max is, but can I find it? Yeah, do you want to complete the square after we just did this? Or you want to just do the -2 or -b over 2a? Probably that route, right? So let's go find the max. If we know we're going to have it, let's go find it. So we're going back to the original. We're going to do -b over 2a, and then we're going to take that answer we get into that. So we've got, that's how we find the max. That's a point. And so what is it? So again, as you go back, you have to kind of, oh dear, I hope I just didn't cut me off. Okay, we'll see if it may not work. It may be done. But anyway, here we go. So remember, the ABCs are found by A, B, C, right? There's your ABC. And so when I look at it, well, what's the opposite of B? -6 over 2 times -1. And then what will that give me? Good. -6 over -2, which will give me 3. And then how do I get the B to go with that? How do I get the B to go with it? I have to plug it in. I'm going to do the opposite. Again, this is parentheses important, of 3 squared plus 6 times 3 minus 8. Now, what's that going to give me? -9 plus 18 minus 8. So you're going to get what? 9 minus 8, which would give you 1. So now we know a lot. Could I sketch that graph without ever picking up the calculator? I know where the max is. I know where the x-intercepts are. And I know it's going down. I have pretty good indication. I've got 3 points. And how many points did I say that we need to use to graph? At least 3, right? At least 3. That's what we've always said when you graph, at least 3. So you have a lot of information. Now it just depends on what they want you to do. Good? All right. So now here we are. I think we're just about done. Well, it looks like we still have a lot left to do. So we're going to try to get through the rest of it. So now it says write the equation in standard form. First question, as soon as you see that, what's the equation in standard form? Y equals A, x minus h squared plus k. Write the equation in standard form. So if you've never really used notes much, I think this will probably be a very good example of when you do go back and look at different kinds of examples. So I drew a picture, and again, you can't see it very well, and I apologize, but that's the point 1, 2, and I think you can see it better in your notes. And that's the point 3 what? Because you can't see it up here at all. 3, -6, and this is the point 1, 2, right? I don't know if you can see that very well, so I'm going to go and draw that out there. So here's the catch, because there's 2 parts in your homework. There's a part where it just gives you the letters, it just gives you the written part with no picture. And then sometimes they just give you the picture and say write an equation based off of this information. So really, you're not going to have both. You're going to have just the written part, or you would have just the picture. But the process is the same. So my first thing is what's the given? What's the known fact that we see in the problem because we see the problem? You have the vertex, right? We know the vertex is right here. We know it has the max, and we also know we're going to have a what out front because the way it looks, negative. So those are things we want to be able to kind of keep up with. And so when I look at this, you're going to do y equals a We already did a little bit of this, but about writing equations with transformations. How am I going to put that 1 in there for the h? Because remember, this is your h and this is your k. So it's going to go in as x what? Minus 1 squared. Then what? Plus 2. I only have one more thing to do, and that's to find the what? The a. That's all I got. And so we're going to kind of go back to old school. You remember how we have point slope formula? And then we have y equals mx plus b. And some teachers taught you to do y equals mx plus b with plugging in an x and a y to get your b. Well, that's what we have to do. We have to do the same thing to get our a. You have to plug in an x and a y to get your a. And well, looky here. Here's the extra x and y. Oh, here's the extra x and y. And so we plug that in. So we're going to plug in -6 equals a times 3 minus 1 squared plus 2. And again, this is where some people get a little bit upset. It's because order of operations. And I'm going to tell you right now, phones should be away and ear pods should be out. I don't know, some of you, those are like my number 2 rules. And as I glance over, I got ear pods in and I got people on their cell phone. So those need to go away. We look at this and what are you going to get? You're going to get -6 equals a times what? 2 squared plus 2. And here's where most people make the mistake. Are you supposed to multiply or add first? Multiply. So this becomes -6 equals 4a plus 2, right? Because it's 2 squared and we get a 4. So people want to just make that 6a or they don't know what to do. They get lost in the shuffle there. And so now what we do to solve for a? Subtract 2. You get -8 equals 4a. You divide both sides by 4. You get what? -2. Oh, there's that negative we needed because the graph is going down, right? There's that negative we needed because the graph is going down. Now we're finally done. What's the equation? Y equals a -2 x minus 1 squared plus what? 2. And we can tell our transformations if we want to. It's going to reflect over the x-axis, going to vertically stretch by 2, went to the right one, up 2, right? So lots of stuff you can still tell from the graph. This just telling you about the vertex. We already talked about that, right? I decided it'd be better just to join it together instead of trying to keep the things going forever. Okay, same thing, just kind of explaining the rest of it. Again, if a is greater than 0, we know we're going to have a what? Minimum. If a is less than 0, you know you're going to have a what? Max. We said, hey, we can quickly find that by doing -b over 2a. Do you agree? And then how do you find your y coordinate? You go plug it in, right? So we already did that. I tried to just do a 2-for-1 there to kind of cut all that out. And the very last thing, we're going to have one little word problem, and then we should be able to call it a day. So if the bell rings, let's get through the example, hopefully. All right. So it says the path of a baseball is given the function blah, 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 where f of x is in height. So your y value is the height. If I were to graph the thing, this would be your height. And then of the baseball in feet. X is the what? Horizontal what? Distance from home plate. That's the horizontal distance from home plate. So that's telling you how far away it is from home plate, correct? So it's the horizontal distance. It's telling you how far away it's going to land from home plate. What's the maximum height for each of the baseball? You need the maximum height. How are you going to find it algebraically? Again, you know it's negative, so you know it's going to go down. You know you're going to have a max. Hence, that's why they're asking you for a max. And how are you going to get it? What's the quickest way to get it? -b over 2a. Would I want to use a bunch of decimals and try to factor that sucker out? Nope. Would I want to complete the square to try to do that? Nope. I'm going to go for, if I want the maximum height, I know it's at the vertex, and I'm going to do that number. So what are you going to do? You're going to get that it's going to be what? Negative, remember there's your a, b, c right here. So it's going to be -1 over 2 times what? -0.0032. Now I'm going to tell you a number one thing. So I'm going to pull my calculator in here because I'm going to do that math on a calculator. This has to be in parentheses. If you don't put it, your calculator is going to take -1 divided by 2 and then times it. And that's not what you want. And I do think I'm going to have to stop here just so that we get it. So that's going to give you the x value. And then how are you going to go get the y value? Plug it in. And that will be your actual maximum height, correct? The y value would actually be your maximum height. Questions on that? I'm going to go ahead and do that. And then, but I'm going to let you guys go ahead and clean up and take away. You do have some homework if you want to get started on it. I think I've written self-explanatory notes. I would do what you can over the weekend because homecoming is next week for one. And you want to try to have fun all week next week. So that's part of it. And so get some stuff done that you can get done. And make sure that you just kind of follow the directions I was asking, plus pay attention to these. Questions on that? Okay. So we'll close up. Yes.
If they ask for the height, would it be wrong if we just put the Y?
No, because that's what it wants. And that's what I'm about ready to explain there.
Whatever we had to do. That's all I did. I had no idea. I know, I thought it was a funny.